Now let's go through a little bit more complicated versions of drawing molecular geometries or determining the molecular geometries of compounds. And so usually when we have a more complicated situation, we have something that is called an expanded octet. What that really just means is that our central atom, and only our central atom, can have more than 8 electrons attached to it. So a good example of this would be like XeCl4. And then in this class, I will always tell you that how many lone pairs are attached to our center. And so in this case, it has 2 lone pairs of electrons that are attached to this. And so whenever you see something in parentheses with how many lone pairs you have, what you could assume is that you're going to have an expanded octet, and that you can do this where you could follow these following steps. So our first step is to draw the loose dot structure. And how we do this is by assume all bonds are single bonds. And so our central atom in this case is Xe. And so we have an Xe. And then we have 4 Cls, right? Cl4. And so all 4 of these Cls will be attached to our Xe. So we have 1 Cl, 2 Cl, 3 Cl, and 4 Cl. And then what we do is make sure that all the outer elements have 8 electrons. And then obviously this excludes hydrogen. And so in this case, we have Cl. And so each of these chlorines right now has 1 bond, which counts as 2 electrons. And so it needs an additional 1, 2, 3, 4, 5, 6 electrons to have up to 8. And we do that for every single one of these Cls. And then lastly, sorry, I'm going to redraw this one. Remember, I said that there's 2 lone pairs. Those lone pairs are attached to our central atom of Xe, and so all we do is draw 2 lone pairs. Remember, each lone pair is 2 dots, and so we draw 2 pairs of dots attached to our Xe. From this, we then figure out, step 2, sorry, not 3, and that is to find how many electron pairs we have. And so remember, the way we figure this thing out is that electron pairs is equal to the number of bonds plus your number of lone pairs attached to our central atom. Remember, it's only central atom. And so in this case, we only look at Xe, or this element right here. So how many bonds do we have attached to Xe? We have 1, 2, 3, 4 bonds. So we have 4 bonds. So this is for Xe. We're looking at how many electron pairs or EPs we have. We have 4 bonds. Plus, we have already given to us as information is 2 lone pairs. And so we have a total of 2 lone pairs in addition to this. And so we have a total of 4 plus 2, which is 6 electron pairs. And then remember, I said lone pairs is always going to be important. And so in this case, we have 2 lone pairs attached to the center, so we have 2 LPs. We then use the chart to then determine the molecular geometry. And so in this case, we have a compound or a molecular geometry that has 6 electron pairs and 2 lone pairs. And if we use the chart, this is what we call a square planar molecule. And so if we had to redraw this, it would look as such. So we just look at the molecular geometry of the molecule, and we see that the generic one is E in the center. It has one wedge and a dash in the back, and a wedge, and it has X, 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 and then has a line, 2 dots, and a line, and 2 dots. And so all we do is redraw our drawing that we have here to match this drawing right here. So we have XC in the middle. We then have a dashes in the back for one Cl. We have a dash for another Cl. We then have a wedge for a Cl, another wedge for a Cl. We have a line for our first lone pair of electrons, a line for our second pair of electrons, and then we add dots associated to our chlorines. They all have the dots that we associated and drew before. And there is your drawing of a square planar molecule with our example of XeCl4.